there. Dead center of the throat. Go ahead and plot it. So there is shot number 1, and he would do the same for each shot for 10 shots. When this page is done, he goes to the next. Paper's cheap. Finally, it could be a drill, a shooting drill of some kind. It could have a time limit in which he would record how much time he required. It could have involved range estimation, where he would have written in here his estimated distance to the target and the actual one. It's through using a card like this kind of a shooting record, that he ultimately develops this, which is a ballistic data card specifically for his rifle, using all the data for that match grade 308 that he fires. Now, once all this data is together, he knows how high he must compensate for various distances. He knows how to compensate exactly for when. He starts off with book data, modifies it based on real-world experience. Then he can take this card and his ghillie suit, he can glue it right here so that he can look at it as he's getting ready to shoot. He could glue it to the butt of his rifle. Ultimately, he memorizes it. A sniper employs several shortcuts when zeroing his rifle. First, he has a competent gunsmith use a bore sight, so that already there's pretty close alignment between his scope and his rifle barrel. Second, when he arrives on a range, he cuts paper on a target at only 25 or 50 yards, so he's certain that he knows where it's going to hit. Then, he zeroes it for the appropriate distance for his agency. Law enforcement, typically that's 100-yard zero. Some military units, 300 or 600 yards. If you're using a scope with a bullet drop compensator on the top, its specifications will tell you 200 or 300 yards. When you're zeroing, you're going to zero either for a civilian match, such as this Federal 168 hollow point match, or the military special ball M118. They are not specifically the same. If you zero for this, you've not zeroed for this. Secondly, once you have zeroed, also record that lot number, because you will be shooting ammo off just that lot number, and if you must go to another, then you test fire ammo from that next slot and shoot just from it. Here's an array of assorted targets, starting on the left with the zeroing targets. The upper one is actually a little more suited for sniping, because you can clearly see dark lines where you can align the crosshairs of your scope. This is a good general purpose target, just good for bullseye type practice, as well as you can take a black spacer, put it on just about anything. That's a good challenging shot for 100 yards. When you start getting to drills and more realistic practice, a realistic target is suited. The only thing I might change here is to Xerox an actual face and put it over it. When it comes to reactive targets, targets that do something when you hit them, that are fun to shoot, and remember, keep shooting fun, you keep shooters interested. Different colored balloons, it could represent different types of targets. Remember to keep them proportional to the distance, 200, 300, 400 yards. Other reactive targets, you take a dozen milk cartons, put them on a hillside, and now you've got both a spotting exercise and a marksmanship exercise. For 100 yards, shoot raw eggs or golf balls. That's real fun in comradely shoot-offs, a little sniper competition. 200 yards or greater, a clay pigeon. And finally, these Chinese exploding targets. If you can place a round in that orange center, it will go boom in a big way. It's one thing to shoot on a perfect day off a bench. It's quite another to shoot realistically, which means under stress. To drill yourself so you're ready for the rigors, both mental and psychological, of real sniping, you need to induce stress, both physical and psychological. We're going to demonstrate one drill that's designed to do exactly that. Sniper, are you ready?
Ready.
Get down! Get down! They're gonna kill you! Quick! Quick! You're slow! They're shooting! Quick! Quick! Now, I did a dirty trick. He didn't know I was going to shout at him. But the whole point is that to induce that kind of stress, you do such things as, without the sniper realizing it, pour water on his neck just as he's starting to get a sight picture. Or, say, put a boombox radio next to him, and if he likes rap music, you play country western, and vice versa. You need to induce that stress to make the shooting drill realistic. probably the most critical fieldcraft skill a sniper must learn to master, is accurate range estimation. The cause of most long-range misses is inaccurate range estimation. Now, the quickest, most accurate means of range estimation is using a field map or a topographical map. With it, if you have enough landmarks around, such as if you look before us, we've got a saddle, we've got two hills, we've got a dirt road running between them, there's visible water off in the distance. I know I'm on high ground. I can probably accurately estimate all the distances around me purely through using that map. Now, some other techniques, when you don't have a map available or there aren't as many handy landmarks. First, football fields. Many people know what the distance is. It's like a mind's eye thing of how far a football field will look before you. Break it up into these increments of football fields, 100 yards per football field. A second technique is called 1/2 the distance. You use that when the distance is so great that you're concerned you're going to be wrong. Pick a point half that distance, use the football field technique, then double it, and you'll be far more accurate. The last technique is called the thumb technique. This goes all the way back to the old frontier musketeers in the United States, pioneer history. When we're estimating short-range distances, when you extend your arm all the way out and hold up your thumb, it subtends or equals widthwise about what a man's stride would be, or 30 inches at 50 yards. All you have to do is know that if a man is as far away as your thumb and it would take one step to walk the width of your thumb, he's 50 yards away. If it would take 2 steps, he's 100 yards away. If it would take 3 steps, he's 150 yards away. Now, this is only good for short range because once you start trying to divide it up too finely, you'll no longer be accurate. But remember, especially police officers, most sniper engagements are short range, not long range. The sniper team carries 2 optical devices that provide accurate range estimation. First would be binoculars that contain a ranging reticle inside, such as these Steiners, or a quality sniper scope that includes a mil-dot reticle. These little dots are 1 mil apart. Here in these Steiners, we have a scale that shows in increments of 10 mils. You use both to measure distant targets to estimate range. And here's what happens. Either you're using yards or meters all the way through, but it works either way. You estimate the size of an object in mils. That is, you use your binoculars, you look at the object or your rifle scope, and you very exactly measure how large or wide it is in mils. Then you figure out how much real world that object is in yards. For instance, I looked at a distant telephone pole that I know in this area. All the telephone poles are 3 yards high. So I took that 3 yards times 1,000. When I lifted my binoculars to them, I found that they were 8 mils high. Therefore, it is 3 times 1,000, which is 3,000, divided by the 8 mils, which equals 375 yards. This is the most accurate technique, short of using a laser rangefinder. Most long-range shooters eventually learn how to accurately estimate range, but what really ultimately separates the men from the boys is accurately estimating wind, which equally can impact on the accuracy of long-range shots. Let's take a look here. A 90-degree crosswind is what is normally called a full factor. Full factor. That is, here's the target. Wind is directly from your right or left. What confuses a lot of shooters is that an oblique wind from any direction is not 1/2 the indicated ballistic value of a crosswind. It's 3/4 the effect, because that wind so quickly affects the drift of the bullet by virtue of its shape. In fact, by the time it's a 1/4 oblique crosswind, already you should be compensating using half that value. To better understand how wind reacts to the terrain it moves through, visualize the wind as if it were a water current. Looking before us, you can see we've got a variety of lowland, relatively flat. We've got a tree line, a couple of ridges. Now let us assume that the wind is coming, as it actually is here, from right to left. it would roll rather high over the top of these hills. On the reverse slopes, there'd be almost no wind up close.